Welcome to the fourth video on solving trig equations. The goal of this video is to solve trig equations with half angle and multiple angles. We want to solve this equation on the interval from 0 to 360 degrees. And notice what's different about this one is we have half angles. But let's go ahead and approach this in the same way. Let's add sine x over 2 to both sides of the equation. That would give us 2 sine of x divided by 2 equals square root 2. We'll divide both sides by 2. We have sine of x divided by 2 equals square root 2 over 2. This looks just like other types of equations that we solved, except now we have a half angle. What we can do here is let this half angle equal u. Let's rewrite this in terms of u now. We'll have sine u equals square root 2 over 2. We'll solve this like we normally would to find u, and then we'll solve for x in this equation. A ratio of square root 2 over 2 should remind you of a 45-45-90 reference triangle. The sine of 45 degrees would be 1 over square root 2, which would rationalize to square root 2 over 2. So we have a reference angle of 45 degrees. The next thing we have to remember is that sine theta will be positive in the first and the second quadrant. So we have to sketch a reference angle of 45 degrees in the first quadrant and also the second quadrant. And let's go ahead and just label all these sides. So we have two possible angles for u. We could have a 45 degree angle. We could also have a 135 degree angle. Now be careful because our solution needs to be in terms of x, not u. So we can go ahead and replace u into this equation and then solve for x. We can see here to solve for x we multiply both sides of the equation by 2. So x equals 90 degrees and x equals 270 degrees for this problem. Let's go ahead and try another one. Here we have a triple angle. Let's follow the same procedure. Let's solve this for cosine 3x. We'll add square root 3 to both sides. Divide by 2. So again, this looks very familiar, but now we're going to replace 3x with u instead. So we'll have cosine u equals square root 3 over 2. We'll find u and then come back here and find the value of x. And the ratio of square root 3 over 2 should remind you of a 30-60-90 right triangle. The cosine of 30 degrees is equal to square root 2 over 2. So we have a reference angle of 30 degrees. Cosine is positive in the first and the fourth quadrant. So we'll sketch a reference angle of 30 degrees in the first and the fourth quadrant. So we'll sketch two different reference triangles, one here in the first and one here in the second as well. And again, we'll label all the sides of the triangle, and then we'll determine which angles these are. Well, obviously the first one is 3 degrees, and the second angle would be 360 minus 30, or 330 degrees. Again, that's what u is equal to. We want to find the value of x. So using this equation now, we have 30 equals 3x. Dividing both sides by 3, we have x equals 10 degrees. And for u equals 330, we have 330 equals 3x. Dividing both sides by 3, x equals 110 degrees. So it's important to remember when we do this substitution, we have to go back and find the value of x. Now this problem is a little bit different. We have cosine 2 theta and a cosine theta. Since these angles are not the same, we're going to have to perform a substitution. Remember that cosine 2 theta is equal to 2 cosine squared theta minus 1. So we're going to perform the substitution for cosine 2 theta. This is in quadratic form, so let's go ahead and put these terms in descending order. This is factorable. 2 cosine theta, cosine theta. Now we have to play around with the factors of negative 1. If we put a minus 1 here and a plus 1 here, the outer product is negative 2 cosine theta plus the inner product of 1 cosine theta equals the middle term. Now we'll set each of these factors equal to 0. If we set this equal to 0 and solve for cosine theta, we'd have cosine theta equals subtract 1 divided by 2. And over here we'd have cosine theta, add 1 to both sides, we'd have cosine theta equals 1. Back to our reference triangles for cosine theta equals negative 1/2. Back to the 30, 60, 90. The cosine of 60 degrees is 1/2. But we want negative 1/2. Cosine is negative in the second and third quadrant. So we'll sketch a reference angle of 60 degrees in those two quadrants. This would be 120 degrees. The second angle would be 180 plus 60, or 240 degrees. Next, we want to know where cosine theta is equal to 1. Remember, on the unit circle, cosine theta is equal to the x-coordinate. X is equal to 1 right here at this point on the unit circle, and this angle would be, on the given interval, we're going to use 0 degrees, or 0 radians. And I also noticed that they did want our answers in radians. Let's go ahead and convert these to radians. 2 pi over 3 radians. And this would be 4 pi over 3 radians. And I think we're good on this problem. I think we have time for one more. Again, notice we have sine theta minus sine 2 theta. Since this is a single angle and this is a double angle, we can't just isolate one of the trig functions. We're going to have to do a substitution using sine 2 theta equals 2 sine theta cosine theta. So let's start off with that. Now, it may be difficult to determine which identity to use to perform the substitution. I've already provided it, so it does make it a little bit easier. So when you're doing these problems, you should have a list of identities handy so you can reference them. Now, even though this is in terms of two different trigonometric functions, there is a common factor with sine theta that we can factor out. So we'd be left with 1 minus 2 cosine theta. Setting each of these factors equal to 0, we'd have sine theta equals 0. Or 1 minus 2 cosine theta equals 0. Let's solve this for cosine theta, so we'll subtract 1 and then divide by negative 2. That would be a positive 1/2. Let's find our angles now. Sine theta equals 0. Remember, on the unit circle, sine theta is equal to y. The y-coordinate would be 0 on the x-axis, so sine theta would be 0 here and here. Again, on this interval we'd use 0 radians, and over here we'd have pi radians. Again, this is the point 1, 0, and this is the point negative 1, 0. The y-coordinate is equal to 0. Next, for 1/2, we'll go back to our 30, 60, 90 right triangle. We're looking for an angle that has a cosine of 1/2. That would be 60 degrees. Cosine is positive in the first and the fourth quadrant because it's equal to x over r. X is positive in the first and fourth quadrant. Let's sketch a 60-degree reference angle in both the first and the fourth quadrant, which would tell us that one angle would be 60 degrees and the other angle would be 300 degrees. They did request our answers to be in radians, so let's convert these to radians. This would be pi over 3. 300 degrees would be 5 pi over 3. Okay, I think that'll do it for this video. Hope you found it helpful. Have a good day.